So hello students, so let us start with the discussion of paper 2. So JEE Advanced 2025 that happened on May 18. So we are discussing paper 2 right now, chemistry paper 2. So let us start. So paper 2 was divided into 3 sections. The first section was containing 4 questions that were single choice. So for single choice question, the marking scheme was +3 and -1. So for single choice question, the marking scheme was +3 and -1. There were 4 questions single choice. So let us start with the first question. So first question is saying, during sodium nitroprusside test of sulfide ion, in an aqueous solution, one of the ligand coordinated to the metal ion is converted into. So what is sodium nitroprusside? So first of all, sodium nitroprusside test is done for sulfide ion. So compounds containing sulfide ion, sodium nitroprusside, FeCN5, NO. So this is sodium nitroprusside. So sodium nitroprusside is added to any salt. Suppose the salt is sodium sulfide. So in sodium sulfide, to detect the presence of sulfide ion, sodium nitroprusside is added. And the complex formed is giving blue or violet coloration. So formation of blue or violet coloration confirms the presence of sulfide ion. So what is the complex form? CN5NOS. So this is sodium nitroprusside, which is added to sulfide ions to detect the presence of sulfide ions that you must have studied in salt analysis. So this will give me sodium thionitroprusside. So this is known as sodium thionitroprusside. So sodium thionitroprusside will be formed. So this is sodium thionitroprusside or sodium, also known as sodium sulfonitroprusside. So this can be sodium thionitroprusside or sodium sulfonitroprusside. So that is getting formed. Now question is asking, during sodium nitroprusside test of sulfide ion in aqueous solution, one of the metal ligand coordinated to the metal ion is converted into. So the metal ligand, one of the metal ligand. So this is the metal ion in which there are 5 cyanide ligands and 1 NO ligand. So this NO ligand is getting converted into NOS ligand, right? And if you see options over here, NOS minus is there in the option, SNO minus is also there in the option. So if we go to the structure of sodium nitroprusside, so sodium nitroprusside, if we go to the structure, so there is this iron that is bonded to 5 of the cyanide ligand. The coordinate bond is between carbon and the iron atom. So cyanide ligand 5 are there and 1 NO. So the bond is between the nitrogen and iron atom. So this is the complex FeCN5NO. The charge is 2 minus. So for this complex over here, the charge is 2 minus, and if you calculate, NO is also neutral, cyanide is -1. So iron over here is in +3 oxidation state. So oxidation state of iron is +3 over here, and in this complex NOS minus, cyanide is also -1. So iron is in, so overall the complex, the charge is -4. FeCN6NOS, the charge is -4. Iron is in +2 oxidation state over here. So when this is converting into this, so what is the change in the complex? So this complex is getting converted into this complex. There are 5 cyanide ions bonded to the iron, and this N double bond O and S minus. So this will be the complex, and the charge of this complex is -4. Over here the iron is in +2 oxidation state. Over here the iron is in +3 oxidation state. So this is the overall reaction in which the oxidation state of iron is also changing. So violet coloration confirms so it is not a precipitate. Violet coloration confirms the presence of sulfide ion. So iron, the oxidation state is changing, and in the ligand, if you see in the metal complex, the NO, sulfide S will get attached, and the negative charge is there on the sulfur atom. The coordinate bond is through the nitrogen atom, and the negative charge is there in the sulfur atom. So if you see the option A will be correct. It is showing that negative charge will be through the nitrogen atom, and the coordinate bond will be through nitrogen atom, and the negative charge is on the sulfur atom. So option C will not be correct because it is showing negative charge on the oxygen atom. So one of the ligand coordinated to the metal ion is converted into NOS minus will be the answer. That is option A is the answer. So this was question number 1. Next question. So let us come to the second question. Second question is saying the complete hydrolysis of ICl, ClF3, BrF5 respectively gives. So this is also a question from interhalogen compounds. As you can see, ICl, ClF3, BrF5 are interhalogen compounds. So if interhalogen compound is undergoing hydrolysis, suppose X dash is an interhalogen compound. If that is undergoing hydrolysis, so the product form will be HX plus HX dash O. So this will be known as, so suppose X is the smaller halogen. So over here there are 2 halogens. Suppose X is the smaller halogen. So smaller halogen will be more electronegative element. More electronegative halogen will be at the negative oxidation state over here. And the bigger halogen, so X dash is the bigger halogen. So X dash is the bigger halogen. So X dash is the bigger halogen, that is less electronegative halogen, that will be at the positive oxidation state. So oxidation state of X dash will be 1 plus 1. So whenever an interhalogen compound is undergoing hydrolysis, the more electronegative halogen will be at the negative oxidation state, and less electronegative halogen will be at the positive oxidation state. So if this type of XX dash type of interhalogen, if XX dash type of interhalogen compound is undergoing hydrolysis, so we'll be getting hyperhalous acid. So this is hyperhalous acid will be formed in this case. So in the case of ICl, it is an interhalogen compound. The more electronegative halogen, that is chlorine, will have a negative oxidation state, and the iodine will be at the positive oxidation state. So this will be known as hyperiodous acid. So hyperiodous acid will be formed. The question is asking the ions basically. So hyperiodous acid, the ion is IO minus. So ICl, the ion formed is IO minus. Now for the second type of interhalogen compounds. So if the interhalogen compound is of the type X-3, where X is more electronegative halogen, that is the smaller halogen, and X dash is the bigger halogen. And so the more electronegative halogen will be at the negative oxidation state, and another next halogen will be at the positive oxidation state. So in this case, halous acid will be formed. So halous acid will be formed. So ClF3 type of compound is of this type. So this on hydrolysis will give me fluorine is more electronegative, that will be at the negative electron oxidation state. So HF will be formed and HClO2 will be formed. So this is chlorous acid. Halous acid, that is chlorous acid, is formed in this case. So the ion coming is ClO2 minus. So from the second ClF3, the ion coming is ClO2 minus. Right? Similarly, for the third type of interhalogen compound, that is of the type X X dash 5. So in this case, it will give me on hydrolysis, it will give me HX plus HX dash O3 will be formed. So that is known as halic acid. Halic acid will be formed in this case. And if the interhalogen compound is of the type XX-7, this one on hydrolysis will give me HX plus HX-O4. That is perhalic acid. Perhalic acid will be formed. In this case, and this one is halic acid. So BRF5. So BRF5 on hydrolysis. So this is XX dash type of interhalogen compound. So the more electronegative halogen will be at the negative oxidation state. So HF will be formed and the bromine will be at the positive oxidation state. So HBrO3 will be formed. That is nothing but bromic acid. So bromic acid will be formed in this case. So the ion that is coming is BrO3 minus. So BRF5, the ion is BrO3 minus. So clearly the answer is option A. So this is the answer. Next question. Monocyclic compounds PQRS are the major products formed in the reaction sequence. So PQR and S. So PQR and S. So this is the complete question. So the PQRS, the major product formed. Monocyclic compounds are there. PQRS, all are monocyclic compounds. And they are the major products of these reactions that is given in the question. Question is asking the product having highest number of unsaturated carbon atoms. So let us make the products first. So let us make the product for P. So what is P basically? So bromine, red phosphorus, hydrolysis. This is HVZ, Hell-Vollard-Zielinski reaction. So the substitution of bromine will take place at carbon adjacent to the carboxylic group. So this is allylic substitution. So over here bromine will be substituted to the carbon adjacent to the carboxylic group. So this is basically the structure of P. Now unsaturated carbons. Over here unsaturated carbons are 6 in the benzene ring. So unsaturated carbons in P is 6. Now for the second one is basically acetone that will show aldol. So cross aldol will happen with benzaldehyde. So base like NaOH will take this acidic hydrogen, then this will attack, and after aldol dehydration will also take place. So I am making the final product of alcohol. So dehydration of alcohol to give alpha beta unsaturated compounds. So this is the final product. In this 6 plus these 2, 6 plus 2, 8 unsaturated carbons are there in Q. Now in the third one, this is terminal alkyne, C triple bond CH. So this is NaNH2 is a base that will take this acidic hydrogen. So after taken, the acidic hydrogen is taken by this NH2 base. So this alkyne, terminal alkyne, the carbon ion of the terminal alkyne will act as a nucleophile and will do the substitution of this bromine. So this bromine will be substituted and C double bond C. So this will attack this carbon atom and substitute the bromine, and over here benzene ring. And the second step is hydrolysis. So hydrolysis of alkynes will give me this ketone. So ketone will be formed as the final product over here. So over here the number of unsaturated carbons are 6 over here and 2 of this. So you will count 6 plus 2, 8 for R. So unsaturated carbons are 8 for R. So P is 6, AQ is also 8, R is also 8. You have to tell the maximum basically. So maximum, let us see the next option, that is S option. So if it is more than 8, this will be the maximum. So highest number of unsaturated carbons you have to tell. So till now we have got 8, that is for 2 options, Q and R. Now let us see S option, ozonolysis. Ozonolysis, what will happen? This double bond will be broken, reductive ozonolysis, aldehyde and ketone will be formed. So what will be the product of this? CH2, C double bond O, CH3, this will be the product, and over here C double bond O, H. So aldehyde will be formed over here, and over here ketone will be formed. So this is the product after ozonolysis. Now two equivalents of CH3MgBr. So the aldehyde and ketones with Grignard's reagent will give me the respective aldehydes and ketones. So this will be the alcohol. Aldehyde and ketone with Grignard's reagent will give me the respective alcohol. So this will be the alcohol formed in this case. And over here, one more CH3 group will attach, and this is the alcohol formed in this case. Now hydrolysis, basically acidic medium dehydration of alcohol. So acidic medium heating dehydration of alcohols will give me alkenes according to Markovnikov addition. So alkenes will be formed, more substituted alkene will be formed. So over here dehydration of this alcohol will give me this alkene, which is more substituted, and this alcohol will give me this alkene. So this will be the alkene formed in this case. So this is the final product. Now this is S basically. Now in this S, number of unsaturated carbons, 6 are there in the benzene ring, 2 these carbons and 2 these carbons. So 6 plus 2 plus 2, total is 10. That is maximum in S. So answer is S. So S is having maximum, that is 10 unsaturated carbon atoms. Next question. The correct reaction sequence that would produce a dicarboxylic acid as the major product. So which of the following reaction, 4 reactions are given, which is producing dicarboxylic acid. So let us check the A option. A option, the chlorine will be substituted. So substitution of chlorine with CN group will be there, and there will be one chlorine with CN. So there is OH, and on this carbon atom the CN group will attach, and hydrolysis in the basic medium, and then finally acidic medium will get the carboxylic acid will be formed. So this is only monocarboxylic acid, we need dicarboxylic acid basically. Then second option, bromine will do oxidation of this aldehyde. Only aldehyde will be oxidized, alcohol will not be oxidized. So this is the product of oxidation with bromine. So only one carboxylic acid is there in this, dicarboxylic acid is not there. Now alcoholic KOH will do elimination of bromide to give alkene, alkyde to give alkene. Now KMNO4 will do oxidation of this, double bond will be completely oxidized, and in this case we will be getting dicarboxylic acid. So both the double bond will be completely oxidized to carboxylic acid. So in this case we are getting dicarboxylic acid. So C will be the answer. You can check the D option also. So chromic acid. So chromic acid will only oxidize this alcohol. It will not oxidize this ketone. So alcohol will be oxidized to carboxylic acid. So you are getting only monocarboxylic acid in D option. So dicarboxylic acid you are getting in C option only. So that is the answer. So next come to the section 2, that was multiple choice question with more than one option correct. There was partial marking in this. So marking scheme was +4 and -2. So if you are selecting any one of the wrong option, you will get -2 even if you have selected the correct options. But if you have selected only correct options, suppose there were 3 correct options and you selected only 2, you will get +2. Suppose there were all the 4 options were correct and you have selected only 3 correct options, you will get +3. Suppose there were 2 correct options or 3 correct options, but you have selected only 1, you will get +1. So partial marking was also there. So let us start with the section 2. So first question of section 2, that is question number 5 of the paper, is saying that the correct statement about intermolecular forces is the potential energy between 2 point charges approaches 0 more rapidly than potential energy between a dipole, point dipole and a point charge. So there is point dipole and a point charge. So in point dipole and a point charge, force is inversely proportional to r cube and potential energy is proportional to r square. In normal 2-point charges, the force, electrostatic force, is proportional to r square and the potential energy is proportional to r. So for point charges, potential energy is proportional to r, and for point dipole and point charge, potential energy will be proportional to r square. Now question is saying potential energy between 2 points approaches 0. So when r is tending towards infinity, potential energy in both the case will be tending towards 0. So when r is tending towards infinity, potential energy in both the cases will be tending towards 0. Now approaches 0 more rapidly. Potential energy between 2 point charges approaches 0 more rapidly than potential energy between a point dipole and a point charge as the distance between them approaches infinity. Now if the value of r is increasing, so this is r square, this will be approaching towards 0 more rapidly. So the potential energy of point charge and point dipole will be tending towards 0 more rapidly. So this will approach towards 0 more rapidly than 2 point charges, because over here only r is there, over here r square is there. So as the value of r is increasing, this will be tending towards 0 more rapidly. So the first statement is incorrect. So A option is incorrect basically. So the potential energy for a point dipole and point charge will be approaching 0 more rapidly, not the 2 point charges. So A option is incorrect. We have to tell the correct statement. So let us move to the next option, B option. B option is saying the average potential energy of 2 rotating polar molecules that are separated by a distance r. So for 2 rotating polar molecules, basically potential energy is inversely proportional to r raised to power 6 and the electrostatic force is proportional to r raised to power 7. So 2 rotating polar molecules are nothing but, you can assume it to be 2 dipole. So induced dipole. Here the rotating polar molecules, the potential energy is inversely proportional to r raised to power 6. So B option is also incorrect. So you have to select the correct option. Next option, C option. Dipole-induced dipole average interaction is independent of temperature. That is correct. So dipole and induced dipole interaction, average interaction energy is independent of temperature. So C option is correct. And D option is saying non-polar molecules attract one another even though neither has a permanent dipole. So non-polar molecules will attract one another even though neither has a permanent dipole. So that is also correct. So the non-polar molecules, one non-polar molecule can induce a dipole in another, another can induce dipole in the first molecule. So these type of forces are known as London dispersion forces. You must have studied. So London dispersion forces or London forces. So or induced dipole forces basically. So non-polar molecules attract one another even though there is no permanent dipole. So it is because of induced dipole in both the molecules. So induced dipole forces that are known as London dispersion forces. So D option is also correct. So correct answer for question number 5, multiple choice question, answer will be C and D. Next question. So question number 6, the compound with pH bond is or are, multiple choice question is there. So phosphoric acid, H3PO4. So if you see the structure of phosphoric acid, there is no phosphorus hydrogen bond. So phosphorus is bonded to oxygen atom and there is oxygen hydrogen bond. So pH bond is absent in this. Now H3PO3, phosphorus acid. So this is phosphoric acid, and in phosphorus acid, there is one pH bond. So pH bond is there. Then this is pyrophosphoric acid. This is formed by heating phosphoric acid. So pyrophosphoric acid, there are 2 phosphorus atoms and there are 4 hydrogen atoms and 7 oxygen atoms. So all the phosphorus atoms you can see from the structure only are bonded to oxygen atom. There is no phosphorus oxygen bond in pyrophosphoric acid also. Then H3PO2. H3PO2, there are 2 phosphorus hydrogen bond. So hypophosphorus acid, so it is having 2 phosphorus hydrogen bond. So answer for this question will be B and D option, multiple choice question. Answer will be B and D. Next question, question number 7. For the reaction sequence given below, the correct statement are KMnO4, so KMnO4 is there, and H plus ion heating. So then ammonia heating minus 2H2. So what will be X? Let us first form X. So KMnO4, oxidation of side chain of attached to the benzene ring. So no matter how much is longer is the side chain, so where it should have 1 alpha hydrogen, it will be completely oxidized to carboxylic acid. So from both the sides, it will be oxidized to carboxylic acid. So this will be on oxidation with KMnO4 and acidic hydrolysis. Now reaction with ammonia, amide will be formed. So finally, what is the structure of X? So what will be the structure of X? Amide will be formed. So ammonia water molecule will come out of the carboxylic acid and amide will be formed. And on strong heating. So basically, first of all, we are getting phthalic acid in this case. So this is phthalic acid. And this is phthalimide. Then over here on strong heating, these 2 amide molecules will combine to give me imide. So imide will be formed, that is phthalimide. Imide will be formed, phthalimide will be formed. Now alcoholic QH will take this hydrogen of phthalimide is acidic because the conjugate base is resonance stabilized. So phthalimide alcoholic QH will take this acidic hydrogen. Now this will act as a nucleophile and it will do substitution in alkyl halide. So alkyl bromide will be substituted and R will attach over here. So what is the final product Y? The final product Y will be alkyl group, that is R is attached to the nitrogen. So this will be Y. This is X. Now Y with NaOH. So NaOH, what will happen? Hydrolysis will take place. So amide group, this will undergo hydrolysis. COH will be formed. Basically sodium salt will be formed. NaOH is there, sodium salt will be formed. That is the aromatic compound and this will come out as amine. So RNH2. This is Z. So this is Z. RNH2 will be the amine, primary amine. So this is the overall reaction that is happening in this question. Now question is asking correct statements. First statement is both X and Y are oxygen containing compound. So X is having oxygen, Y is also having oxygen. So first statement is correct. Both X and Y are oxygen containing compound. Now Y on heating with chloroform. So QH. that is basically forming isocyanide. So that is the test for primary amine. So primary amine will give me isocyanide test. So Y is not a primary amine. So this will not give me isocyanide test. So Y will on heating will not give me this isocyanide test. That is only for primary amine. Foul smelling isocyanide is getting formed. Now Z reacts with Hinsberg reagent. So Z is primary amine. So primary amine can react with Hinsberg reagent. So over here, it will react with Hinsberg reagent, SOCl, SO2Cl. So what will be the product form? So Z will react with Hinsberg reagent. So primary and secondary amines is reacting with Hinsberg reagent. So this is the test to distinguish between primary, secondary and tertiary amine. So primary and secondary amines react. So Z will react, Z is a primary amine, that will react with Hinsberg reagent to form sulfonamide. And fourth option, D option, is saying Z is an aromatic primary amine. So Z is a primary amine that we know, but Z is not aromatic. If Z was aromatic, so when we were doing substitution of this alkyl bromide with amide, amide will attack the bromide and substitution. If bromine is there attached to the aliphatic amine, basically this is an aliphatic amine, bromine will undergo substitution. If bromine is attached to the benzene ring, that is aromatic, if R is aromatic group, then the substitution with amide is not possible and the product would not have been formed. So clearly over here R is an alkyl group, or basically RBr is alkyl halide, and the amine formed is primary, but it is not aromatic. So it will not be aromatic, otherwise over here substitution would not have been taken place. So Z is not an aromatic primary amine, so that is also wrong. So correct answer for this will be A and D option. Come to the next question. For the reaction sequence given below, the correct statements are: so lithium aluminium hydride. So this will do reduction of this amide group. So one alcohol will be formed over here. So first of all, this will be reduced to aldehyde and this to alcohol. Then aldehyde will be further reduced to alcohol. So basically you are getting 2 alcohol. So over here, phenyl is attached over here. And this will be reduced to alcohol. And this part is also reduced to alcohol. So both these groups are same. So this is optically inactive. So question is saying P is optically active. That is wrong. So these two groups will be same. So one alcohol over here. So the compound will be something like this. So there is no chiral carbon, it is optically inactive. These two groups will be same. Now chromic acid, basically chromic oxide with sulfuric acid will form chromic acid. So oxidation with chromic acid, these alcohols will be oxidized to the respective carboxylic acid. So the compound form will be carboxylic acid. So this is Q, and decarboxylation of carboxylic acid will give me alkane. So R will be, so this will be the structure of R after decarboxylation. Now P was this compound. Now P with sulfuric acid. So sulfuric acid will cause dehydration. So dehydration of alcohols will give me alkene. So alkene will be formed. So question A option is incorrect. P is optically inactive. So A is incorrect. Now B option is saying S gives Bayer's reagent. So this is S. So Bayes test is given by alkenes. So this is having unsaturated hydrocarbons, double bond. So this will give the Bayes test. So S will give the Bayes test. Now Q gives effervescence with sodium bicarbonate. So Q is carboxylic acid, which is more acidic than carbonic acid, and this will give effervescence with sodium bicarbonate. So carboxylic acids will give effervescence with sodium bicarbonate. And R is an alkyne. So R is not an alkyne, R is an alkane with benzene ring. So it is not counted in alkyne. So this is wrong. So answer for question number 8 will be B and C option. So the section 3 of paper 2 was containing 8 questions which were numerical value. Numerical value means up to 2 decimal places. So up to 2 decimal places you have to give the answer. So up to 2 decimal places, exact answer should be there. So the negative marking was not there in the section 3. So +4 or 0. So ideally everyone should have attempted all the questions. So let us start with the questions of section 3. So first question of section 3, that is question number 9 of the paper. The density in grams per centimeter cube of the metal which forms a cubic closed packing. So what is cubic closed packing? That is nothing but face centered cubic packing lattice with an axial distance edge length. So edge length is given 400 picometer. That is 400 into 10 to the power minus 12 meter. 4 into 10 to the power minus 10 meters. So density you have to find out in grams per centimeter cube. So for density, formula for density is effective number of atoms in that packing into molecular weight of the atom divided by Avogadro's number and into the cube. So cubic length into cube. So volume of the cube, that is A cube. Right? So over here, basically the density we have to find out in grams per centimeter cube. So grams per centimeter cube we have to find out density. So in FCC packing, that is cubic closed packing, effective number of atoms are 4 and the molecular weight is given out to be atomic mass of the metal, that is 105.6 divided by Na, that is also given 6 into 10 to the power 23. And if you want density in grams per centimeter cube, basically the A edge length you have to take in centimeters over here. So effective number of atoms are 4. Molecular weight is basically for 1 mole, that is for 1 atom it is 105.6 AMU. So molecular weight for 1 mole will be 105.6 grams. So molecular weight we are taking in grams and the edge length we have to take in centimeters. So 4 into 10 to the power minus 8 centimeters. So A cube will be 4 into 10 to the power minus 8 whole cube. So this will give me the density in grams per centimeter cube. So 4 into 105.6 by 6 into 10 to the power 23, 4 cube, 4 into 4 into 4 into 10 to the power minus 24. So 1 4 will get cancelled out. So if you divide this by 3, this will be 52.8. So this will come out to be 52.8. 23 and minus 24, 10 to the power minus 1. So 3 into 4 into 4. So again dividing by 4, this will be how much? So 4 7s are 8s are 8.2. Then again 8.2. 8.2. Then you can divide this by 2, 4.1. Sorry. So 4 into 105.6 by 6 into 10 to the power 23 into 4 cube, that is 4 into 4 square, that is 16 into 10 to the power minus 24. So first of all, 1 4 will get cancelled out. So 10 to the power 23 and minus 24 minus 1, that will go up and will become plus 1. So 1056 by 6 into 16. So let us divide this by 4 again. So 4 2s are, then 6 are, 4s are. Then again dividing by 4. So 666. Then you can directly divide. So 11 grams per centimeter cube will be the answer. So the density is coming out to be 11. So answer will be 11.00 with plus sign. So numerical type question, you have to give answer up to 2 decimal places. So answer will be 11.00 with plus sign. Next question, question number 10. The solubility of barium iodate. So iodate is IO3 minus. So barium iodate is BaIO3 whole twice. The solubility of barium iodate in an aqueous solution prepared by mixing 200 ml of 0.01 molar barium nitrate. So barium nitrate is there. Barium nitrate. So 0.01 molar, 200 ml. It is mixed with 100 ml of 0.1 molar sodium iodate. So sodium iodate NaIO3. This is 0.1 molar, 100 ml of this. That will give me NaNO3 sodium nitrate plus BaIO3 whole twice. Solubility product of barium iodate is also given 10 to power minus 9. That means it is very weak or sparingly soluble, very less soluble. So in this mixture of barium nitrate and sodium iodate, what will be the solubility of barium iodate? We have to find out. Let the solubility of barium iodate, that will give me 2 barium ion plus twice of iodate ion. So let the solubility of this be S dash in this. So S dash of this and 2S dash of this will be formed. Right. Now already some of the barium iodate would have been precipitated because its solubility is very less, 10 to power minus 9. So if I see, you can see the concentration of barium ion over here will be 0.01 was the molarity of barium nitrate. Initially volume was 200 ml, now the volume was 200 plus 1, 300 ml is the volume. So the concentration of barium ion in this will be into 2 by 3. So that is 0.02 by 3 molar will be the concentration of barium ion in this solution. And the concentration of iodate ion, IO3 minus ion, in this solution will be, initial was 0.1 and now it will be into 1 by 3, 100 ml and total is 300 ml. So 0.1 by 3 molar. So you can see the solubility, the product reaction quotient of this is much higher than this value. So most of the barium iodate will be precipitated out. So how much of barium iodate will be precipitated out? That will depend upon basically the limiting reagent. Which one is the limiting reagent over here? You can clearly see the barium ion will be the limiting reagent. So it is 0.02 by 3. That will be completely precipitating into barium iodate first of all. It will not be remaining. And iodate ion, initially it was 0.1 by 3. Now if 1 mole of barium ion is precipitating, then 2 moles of iodate ion will be consumed for this. So number of moles of iodate ion consumed will be 2 into 0.02 by 3. So these will be the moles of iodate ion that will be precipitating out in this. So basically the concentration of iodate ion. So the concentration of iodate ion that is remaining in the solution after precipitation of this will be how much? 0.1 by 3 minus 0.04 by 3, that is 0.06 by 3, that can be written as 2 into 10 to the power minus 2. So this is the concentration of iodate ion remaining in the solution. Barium ion has already precipitated, that was the limiting reagent, and barium iodate has formed. Now in this mixture we have to find out the solubility of barium iodate, that we have assumed to be S dash. So now the concentration of, suppose the saturated solution, the concentration of barium ion will be S dash, that is coming from the barium iodide, and iodate ion will be twice S dash plus the remaining, that is 2 into 10 to the power minus 2. And we know the solubility product is given. So solubility product of barium iodide, so that is given in the question, solubility product of barium iodide. The value is 1.58 into 10 to the power minus 9. 1.58 into 10 to the power minus 9, that is concentration of barium ion and iodate ion square. So this will be the solubility product. So for solubility of barium iodide, the concentration of barium ion from the barium iodide we have assumed to be S dash, and 2S dash is coming from the barium iodide, and already this was there in the solution. Now you can see the value of S dash that will come out, because this is of the order of 10 to the power minus 9. It will be very less as compared to 10 to the power minus 2. So S dash is very less than order of 10 to the power minus 2. So we are neglecting S dash with respect to 2 into 10 to the power minus 2. That is the concentration of iodide ion that is already present in the solution. So from here we'll get the value of S dash by 2 into 10 to the power minus 2 whole square. So 1.58 by 4 minus 5 and plus 5 and minus 4. So minus 9 and plus 4, minus 5 will be there. So minus 9 and plus 4, minus 5. So this will become 0.3 12 338 9 95 into 10 to the power minus 5 molar. So 10 to the power minus 5 can be neglected with respect to 10 to the power minus 2. That is our assumption. This can be also written as 3.95 into 10 to the power minus 6 molar. So question is asking solubility is of the form of X into 10 to the power minus 6. So solubility we are getting 3.95 into 10 to the power minus 6 molar, that is moles per liter, that is moles per decimeter cube. So the answer we are getting 3.95. So the value of X will be, from here the value of X, that will be 3.95. So numerical type question, answer will be plus 3.95. Next question, absorption of phenol from its aqueous solution onto fly ash obeys Freundlich isotherm. So according to Freundlich adsorption isotherm, extent of adsorption X by M is equal to K into P raised to power 1 by N, and we can write down concentration raised to power 1 by N. So Freundlich adsorption isotherm. At a given temperature from 10 milligrams per gram and 16 milligrams per gram aqueous phenol solution. So these were the concentration of the phenol solution. So let me call the first concentration. So the first concentration is 10 milligram per gram, and the second concentration is 16 milligram per gram. At a given temperature from 10 milligrams per gram and 16 milligrams per gram aqueous phenol solution, the concentration of adsorbed phenols are measured to be, so concentration of adsorbed phenol, you can call it the extent of adsorption. So 4 milligrams per gram of the, you can say, absorbate. So extent of adsorption in the first case, let me call this X1, that is 4 milligram per gram, and in the second case extent of adsorption is 10 milligrams per gram. So when the concentration of phenol solution was 16 milligram per gram, the extent of adsorption was 10 milligram per gram of the adsorbate. At this temperature, the concentration of in milligrams per gram of adsorbed phenol from, if the concentration of phenol solution is, let me call this C3, that is 20 milligrams per gram, from that I have to find out the extent of adsorption in milligrams per gram, that is, let me call this X3, I have to find out. The concentration of adsorbed phenol, or at this temperature the concentration in milligrams per gram of adsorbed phenol, extent of adsorption I have to find out, X3. So using the Freinet adsorption isotherm, X1 is equal to K C1 raised to power 1 by N, X2 is equal to K C2 raised to power 1 by N. So X1 by X2, that is 4 by 10, will be equal to C1 by C2, that is 10 by 16 raised to power 1 by N. So this can be written as 5 by 8 and this is 2 by 5. So 2 by 5 is equal to 5 by 8 raised to power 1 by N. So from here we can find out the value of N. Question is giving the value of log 2, that we have to take 0.2. So I am taking log both sides. So 2 by 5 is equal to 5 by 8 raised to power 1 by N. Taking log both sides, so log 2 minus log 5 is equal to 1 by N times log 5 minus log 8. Now log 5 can be written as log 10 by 2. That can be written as log 10 minus log 2. Log 10 is 1 minus log 2. So I am writing log 5 as 1 minus log 2. Log 2 value is given in the question. Log 5 is 1 minus log 2 and this is 3 log 2. So this will be 2 log 2 minus 1 by N of 1 minus 4 log 2. So put the values of log 2, 2 into 0.3 minus 1 is equal to 1 by N of 1 minus 4 into 0.3, sorry. So N will come out to be over here. So 0.2 by 0.4, 1 by 2. So N is coming out to be 1 by 2 from over here. So the value of N is 1 by 2 first of all. Now using this value of N, for the third case we have to find out the extent of adsorption. Basically we have to find out the X3 when the concentration was 20. So again I'll be using this ratio. So X2 upon X3 can be written as C2 by C3 raised to power 1 by N. So X2 was how much? X2 value was 10 and C2 was 16. X2 is 10, C2 is 16, C3 is 20 and X3 we have to find out from here. So putting the value of N, N is 1 by 2, so 1 by N will be 2. So this will be 4 by 5 raised to power 2. That is 16 by 25. So X3 will come out to be 25 into 10 by 16. So 8 5s are 125 by 8. So 125 by 8 will come out to be 15.625. So answer will be 15.625 milligrams per gram. So the answer will be 15.625. Next question. Consider the reaction A plus R is giving me product. A plus R is giving me product. The rate of this reaction is measured to be, so rate of this reaction is rate constant into concentration of A into concentration of R. At the start of the reaction, the concentration of R naught is 10 times the concentration of A, that is A naught. So R naught is 10 times A naught. The reaction can be considered to be pseudo first order reaction with assumption that Kr is equal to K dash. So Kr, K into concentration of R is equal to K dash. So it can be assumed to be pseudo first order with respect to A. Due to this assumption, the relative error in the rate when the reaction is 40% completed. When the reaction is 40% completed, A will be 0.6 A naught. R naught was 10 A naught, out of which 0.4 A naught of R. So 10 minus 0.4. So 9.6 A naught of R will be remaining. So when the reaction is 40% completed, A naught will be 0.6 A naught and 0.4 A naught of R will be consumed. So 10 minus 0.4, 9.6 A naught of R will be remaining. Now we have to find out, due to this assumption, the relative error in rate. Suppose there was no, we are not taking this assumption. So what will be rate in that case? So K, now the concentration of R is 9.6 A naught and the A is 0.6 A naught. So this will be the rate. So that can be written as K A naught square 9.6 into 0.6. Now due to this assumption, what you will take the rate? Let me call this R dash, R1 dash. So R, in that case it will be K dash into concentration of A will be 0.6 A naught. Now K dash can be written as K into concentration of R. That is assumed to be constant. So concentration of R is assumed to be constant, 10 A naught and 0.6 A naught. So that will be K A naught whole square into 10 into 0.6, that is 6. So error, percentage error we have to find out. So error in percentage. So percentage of error will be, so error is how much? 6 minus 0.6 into 9.6 divided by the actual rate. So this is by assuming it to be constant. This is the error rate divided by the correct rate, that will be this rate only, 9.6 into 0.6. In percentage you have to find out, so multiply this by 100. So dividing by 6 you will get, if you are dividing both numerator and denominator by 6, so 1 minus 0.96 upon 0.96 into 100. So 0.04 by 0.96, that can be 4 by 96 into 100. So this will be 24, 100 by 24 or 50 by 12 or 25 by 6. 25 by 6 will be 4.166. So this can be round off to be decimal places 4.17. So 4.17% is the error, that will be the answer. So up to 2 decimal places you have to give the answer. So answer will be 4.17. So question number 13, at 300 Kelvin, an ideal dilute solution of a macromolecule exerts osmotic pressure that is expressed in terms of height of the solution. So density of the solution is given 1 gram per centimeter cube. So the pressure due to height of the solution is H rho g or H dg, where rho is the density, where H is equal to 2 centimeter, H is 2 centimeter. If the concentration of dilute solution is given out to be, concentration is also given 2 grams per decimeter cube. So 1 decimeter cube is nothing but 1 liter. So concentration is given in grams per liter. The molar mass of macromolecule is calculated to be this. So molar mass is this. We have to find out the value of X. So osmotic pressure is given by CRT and the pressure due to height of the liquid was H rho G. So question is saying osmotic pressure is expressed in terms of height of the solution, height of the liquid only. So basically this is the osmotic pressure that is given. So over here we will be working in SI units. So in SI units, when you are working in SI unit, the value of R that you will be taking in joules per Kelvin per mole. So value of R will be in joules per Kelvin per mole. Temperature will be in Kelvin. And SI unit, the concentration will be in moles per meter cube. The SI unit of volume is meter cube, not liters. So over here concentration you will take in moles per meter cube, not in moles per liter. And over here also we are working in SI unit. So height will be in meters. Density will be in kilograms per meter cube and acceleration due to gravity is given in SI unit only, meters per second square. So let us work in SI unit. So height is 2 centimeter. So in meters it will be 2 by 100. Density is given in, density of the solution is 1 gram per centimeter cube. So density is 1 gram per centimeter cube. You can convert this into 1000 kilograms per meter cube. So density will come out to be 1000 kilograms per meter cube. So SI unit we are taking the density and acceleration also given in SI unit, that is 10 meters per second square. That will be equal to concentration. Concentration is given in grams per liter. So 2 divided by molecular weight, that is X into 10 to the power 4. This will be the moles per liter. We want in moles per meter cube. So 1 liter is 10 to the power minus 3 meter cube. So this is the concentration in moles per meter cube. So concentration you can find out first in X into 10 to the power 4. This will be in moles per liter. Then I am converting this into into 10 to the power minus 3. This will be in moles per meter cube. So this is the concentration in moles per meter cube. The value of our SI unit is 8.3 given in the question, and temperature is given 300 Kelvin. So temperature is given 300 Kelvin. We have to find out the value of this X. So 2 and this 2 will get cancelled out. 2 zeros will be cancelling out from over here. So X will come out to be A. Now these 2 zeros and these 2 zeros also you can cancel out. So 8.3 into 3 by 10, you will take 4 and minus 3. So 8.3 into 3 is how much? 24.9 by 10. So 2.49. So the value of X is coming out to be 2.49. That is the answer. Next question, question number 14. An electrochemical cell is fueled by combustion of butane. So combustion of butane, butane is C4H10. The pressure is 1 bar. CO2, 4 CO2 and 5 H2O. So 4 plus 5 by 2, that is 8 plus 5, 13 by 2. So the moles of oxygen is 13 by 2 for this combustion. Pressure is 1 bar and temperature is 298. So standard condition is given. Its cell potential is given out to be cell potential E0. So this is cell potential at this standard condition, that will be called as E0 only basically. So cell potential EMF of the cell is given out to be X by F into 10 to the power 3 volts, where F is Faraday's constant. The value of X we have to find out. So for this reaction, delta G0 can be written as minus NF E0. So delta G0 you can find out from the given over here. So delta G naught for this reaction will be delta G naught of products. So 4 times delta G naught of carbon dioxide, that is minus 394, plus delta G naught of 5 times delta G naught of H2O water, that is minus 237. And so this is products minus reactants. So that is butane, that is minus 18, and 13 by 2 times delta G naught of oxygen. At standard condition, elemental state oxygen delta G naught will be taken as 0. That should be equal to minus NF. Now over here delta G naught is given in kilojoules. So I am multiplying by 10 to the power minus 3. That will give me the answer in joules. I am working in SI unit. So Faraday is also in SI unit I'll take, that is coulomb, 96500 coulomb. Now N, first of all let us find out N for this reaction. N for this reaction will be number of electrons in reduction and oxidation. You can find out N from over here also. Oxygen is going from 0 to minus 2. So there are 13 by 2 into 2, 13 oxygen atoms. So for each oxygen atom there will be change of 2 electrons. So 26 electrons in oxidation and 26 electrons in reduction. You can find out N from the oxidation state of carbon only. So from assuming hydrogen to be plus 1, oxygen over here will be minus 2.5, and over here oxygen will be plus 4. So minus 2.5 to plus 4, change of 6.5 for 1 carbon atom. For 4 carbon atoms, so it will be coming out to be 26 only. So the N for this reaction will be 26. You can find out from oxygen or carbon, anyone. So minus 26 into F into E naught. Now E naught value, you have to take this X by F. So E naught value that is given in the question is X by F. X that we have to find out by F. F will get cancelled out into 10 to the power 3. So from here we have to find out the value of X. You will get the value of X. The value of X will come out to be 105.5. So on solving this equation, you will get the value of X, that is coming out to be 105.5. So that is the answer. Next question, the sum of spin only magnetic moment of Mn Br6 and Mn Cn6. So manganese in both the cases is in +3 oxidation state. Manganese atomic number 25, 4s2, 3d5. Now manganese +3 will be 4s0, 3d4. 3d4 is the electronic configuration. You have to find out the spin only magnetic moment in Bohr magneton. So sum of these two. So first complex, let the spin magnetic moment is mu1, second is mu2. So spin magnetic moment will be n into n plus 2 Bohr magneton. Now number of unpaired electrons in the first case. Number of unpaired electrons in the first case will be, now bromine is a weak field ligand that will not cause pairing. So there are 4 unpaired electrons. Now number of unpaired electrons in the second case, so 3d4 is there. So this will cause pairing, cyanide will cause pairing. So after pairing, 2 will be paired and there will be 2 unpaired electrons. So cyanide is a strong field ligand that will cause pairing of electrons. So over here there will be only 2 unpaired electrons. So mu1 will be under root of 4 into 6, that is 24 Bohr magneton. You can write down 4.9 Bohr magneton. And the dipole moment in the second case will be 2 into 4 Bohr magneton. So 4 will be 2 root 2. So root 2 is 1.414. So 2.828. You can round off to 2 decimal places, 2.83 Bohr magneton. So the sum will be mu1 plus mu2, 4.9 plus 2.83, 7.73 Bohr magneton. So this is the answer. So answer is 7.73. So last question, question number 16. A linear octasaccharide. So octasaccharides, there are 8 molecules joined together, 8 monosaccharides molecules joined together. So molar mass of linear octasaccharides is given. On complete hydrolysis produces 3 monosaccharides. So basically in this octasaccharides there were 3 types of monosaccharides: ribose, deoxyribose and glucose. So there is an octasaccharide that is undergoing hydrolysis. So when a disaccharide is undergoing hydrolysis, 1 mole of H2O will be required. For trisaccharide, 2 moles of H2O will be added. So trisaccharides, 3 molecules are joined together. So 2 bonds will be hydrolyzed and 2 moles of H2O will be added. So for octasaccharide, 7 moles of H2O molecule will be added. So, and these are the 3 types of monosaccharides formed. So molar mass of the octasaccharide is 1024. And on adding 7 molecules of H2O, the total molar mass of all the monosaccharides will be how much? 1024 plus 126, 1150. So the total mass of all the monosaccharides, ribose, deoxyribose and glucose will be 1150. After hydrolysis, water molecule will be added to this and that will give me 8 different molecules of monosaccharide. There are only 3 types of monosaccharides: ribose, deoxyribose and glucose. Now amount of deoxyribose formed is 58.26%. So let the molecules of ribose be X1, deoxyribose is X2 and glucose is X3. So this is an octasaccharide. X1 plus X2 plus X3 will be equal to 8. So total molecules of monosaccharides are 8 and the total mass is 1150. That is X1 into monosaccharide, the ribose, that is 150, plus X2 into the deoxyribose, that is 134 given in the question, and glucose X3 into glucose, that is 180. Now the amount of deoxyribose is 58.26% weight by weight. So total weight of all the saccharides is 1150, out of which 58.26% of this weight is the amount of monosaccharide, that is 2-deoxyribose, that is X2 into 134. So from here you will get the value of X2, that will come out to be 5. So putting the value of X2 to be 5, you will get X1 plus X3 is 8 minus 5, that is 3. So X1 plus X3 is 3. Now the number of ribose unit present in one molecule. So basically you have to find out the value of X1. So over here, we can directly put over here 1150 is equal to 150 into X1, that we have to find out. X2 is coming out to be 5, 5 into 134, and X3 I am writing 3 minus X1. So 3 minus X1 into 180. So on solving this, you can find out the value of X1. So let us solve this. 1150. So 20, 130, 15, 170, 670. So 670 plus 150 X1 minus 180 X1 plus 180, 540. So 180 X1, 150 minus 30. So I am taking it over here. 30 X1 will come out to be 670 plus 540. 1100 and 1210. 1210 minus 1150, that is 60. So X1 from over here is coming out to be 2. So X1 from over here is coming out to be 2. That is the number of ribose unit in one molecule of the octasaccharide. So answer is 2 for this question. So this, in paper 2 there were only 16 questions, but they were lengthy. So accordingly they have given only 16 questions to justify the time that was required to solve these questions, which were a bit lengthy. And the marks were accordingly, the marks were there in the each section. So the paper was lengthy but not difficult. But the objective was to do the questions properly, and though they were lengthy. But your motive should be not to do all the questions, not to score 100% marks. Do whatever questions you know completely, solve it completely, and obtain positive marks and avoid the negative marks.